Wow, you weren't kidding when you said you were diving deep into AI, huh? You even sent us some of your personal notes.
Yeah, it's really impressive, actually. You've got a really thoughtful approach, looking at it from all these angles.
Well, to be honest, I'm a little overwhelmed by it all. That's why I need your help to make sense of it all.
Happy to help. What's really got you hooked?
I think it's just like this feeling that AI is everywhere now, but it's hard to pin down exactly what it is.
Oh, I get it. It's like trying to grab onto smoke sometimes.
Exactly. So, let's cut to the chase. What is AI?
Well, the definition can be surprisingly slippery, but it all comes down to machines doing things that normally take human intelligence. Things like problem solving and making decisions, even being creative.
So not just robots taking over the world.
Well, we're not there yet, at least. But I see why you'd say that it's the classic image. But seriously, what's really mind-blowing is that AI is already all around us. We just don't always realize it.
Okay, that makes sense. I mean, I use Google search a million times a day, but I wouldn't think of that as AI, really.
And that's a perfect example. Google search, it's AI working behind the scenes. Every time you type something in, those algorithms are going through tons of data to find you the best results.
So AI is like the invisible engine behind a lot of our technology.
Exactly. And that engine has had a pretty wild ride so far, actually. Full of stops and starts, not the straight line you might expect.
Yeah, I've heard about those AI winters. Times when the excitement just died down. What happened there? Did we just hit a wall?
It's actually way more complicated than that. Take the first AI winter back in the late 60s, early 70s. Huge expectations, but the tech just wasn't there yet. Like you mentioned self-driving cars in your notes. Back then, even getting a computer to understand a basic picture was a huge challenge.
So it was like a reality check.
Exactly. But those winters weren't failures. They were more like moments to pause and reassess. Researchers shifted their focus, worked on smaller problems, and those breakthroughs laid the foundation for what we're seeing today.
So you're saying understanding the history of AI helps us understand where we are now.
Precisely. And it might even give us some hints about what's coming next.
Okay, so let's dive into those historical milestones, but with a twist. Instead of the usual textbook stuff, let's focus on the moments that connect directly to the questions you have based on the materials you sent us.
I like it. Let's take a trip back in time and see what we can uncover. You know, it's funny you mentioned games in your notes. You highlighted how important they've been in AI development.
Yeah, it's always struck me as odd. Like, if you're trying to create intelligent machines, why start with something as seemingly trivial as games?
I know what you mean. It seems a bit counterintuitive at first. But games actually offer this perfect little sandbox for AI research.
A sandbox?
Yeah, like a controlled environment. You can test algorithms, set very specific goals, and see how well things are working.
So it's a training ground for the AI.
Precisely. And we see this right from the beginning. You mentioned that article about Arthur Samuel's checkers program back in the 50s.
Right, yeah. Wasn't that one of the first examples of a machine learning how to play a game?
It was huge. Because he didn't program in every possible move, he used this method called reinforcement learning.
Reinforcement learning? That rings a bell. Isn't that the same kind of AI that's behind things like AlphaGo beating that world champion Go player? I read about that.
Exactly. It learns through trial and error. It plays the game over and over again and gets rewarded for good moves, penalized for bad ones. Over time, it figures out how to win.
So it's like training a dog with treats, but instead of treats, it gets to win a game of checkers.
Yeah, something like that. And what's really cool about reinforcement learning is it's not just for games. It's got huge potential for things like robotics, medicine, even like tailoring treatments to specific patients.
Okay, that makes a lot more sense now. So games have been this testing ground for these algorithms, showing us what might be possible.
Yeah. And it's not just the algorithms themselves, but also the hardware. Remember that article you sent about Moore's Law?
Oh, right. About how computing power keeps doubling every couple of years.
Exactly. That has been absolutely essential.
Yeah.
Because that exponential increase in processing power lets us tackle problems that were just impossible before, even with amazing algorithms.
It's like we've gone from those massive computers that took up whole rooms to devices in our pockets that are millions of times more powerful.
Precisely. And that brings us to a question you brought up in your notes.
Yeah.
How does AI learn from all of this data? You mentioned machine learning. Let's unpack that a bit.
Yeah, let's do it. I gotta admit, the whole machine learning thing still seems kind of like magic to me. Okay, so we've talked about AI learning from data, but how does that actually happen? It still seems kind of mysterious.
Yeah, it's a pretty mind-bending concept, but basically, machine learning is about finding patterns in data. Think of it like this. Imagine teaching a kid how to ride a bike.
Okay, I'm picturing lots of scraped knees and eventual triumph.
Exactly. Now, you wouldn't hand them a physics textbook and expect them to just get balance and momentum.
Right. Definitely not. You'd probably just give them a push and let them figure it out.
Precisely. And that's kind of how machine learning works. Instead of programming in every rule, we feed the AI tons of data, in this case, maybe videos of people riding bikes.
So the AI is watching these videos and picking up on, like, the subtle things that make someone a good bike rider.
You got it. It looks for patterns. How the rider shifts their weight, how they use the pedals, how they correct themselves when they wobble.
And over time, it starts to understand what makes a good bike rider versus a bad one.
Exactly. And once it's learned those patterns, you can show it a totally new video of someone on a bike, and it can predict if they're about to crash.
Wow, okay. That actually makes a lot of sense. But you mentioned there are different types of machine learning. You brought up neural networks, and I remember that really sparked my curiosity in my research.
Yes. Neural networks. Now, this is where it gets even more interesting. Remember how we talked about neural networks having all those layers? They kind of act like a team of specialists, each one trained to recognize different things in the data.
Okay, so like one layer might be looking for edges in an image, another layer looks for shapes, and so on.
Exactly. The data flows through these layers, each specialist does its thing, and the network as a whole slowly builds up a more and more complex picture.
It's like each layer is adding a piece to the puzzle until you get the full image.
That's a great way to put it. And the amazing thing about neural networks is they can find super subtle patterns, things that we as humans might not even be consciously aware of.
Okay, so that explains why there's so much hype around them. But you also mentioned that even the experts don't fully understand why they work so well. That's kind of freaky, isn't it?
It's true. We can see what goes in, we can see what comes out, and we can tell how well it's doing. But the stuff in between, how those billions of connections create those impressive results, that's still kind of a mystery. People are working hard to figure it out, though.
So we've created these powerful tools, but we don't totally get how they tick.
That's part of what makes it so exciting. There's so much more to discover. The possibilities are pretty much endless. And the fact that you're engaging with these questions, digging into the research, that's what's going to shape the future of AI.
You know, that's a great point to wrap things up on. We've explored the history of AI, the nuts and bolts of how it works, but even more importantly, we've connected all of this to your curiosity and the questions you had from digging into this stuff yourself.
Absolutely. Keep those questions coming, keep learning, and who knows, maybe you'll be the one making the next big breakthrough in AI.
That's all the time we have for today's deep dive, but this is really just the beginning of the AI journey. There's so much more to explore. Until next time.